Hi, welcome to lesson number 5, module 3 of the Big Data and Hadoop Developer course. So in this particular lesson, we will be demonstrating the anatomy of a file write and read in HDFS. Now before we proceed with the lesson, let's have a quick recap of the previous lesson. Now in the previous lesson, we learned about the HDFS architecture by way of getting an idea of concepts like anatomy of a file read and write. We saw that the file write process is sequential, however, the file read process is parallel in HDFS. So in this lesson, we'll be demonstrating some basic file operations in HDFS. And if you are familiar with Linux or Unix operating system, then this is going to be a cakewalk for you because most of the file operation commands in HDFS are related to Linux or Unix commands for the same operation. So before we proceed with the lesson, let me summarize what are we going to do. Now, we are going to use certain commands such as the put command, which is used to upload a file into Hadoop, get command, which is used to download a file from Hadoop, the ls command to list the files, mkdir or the make directory command to create a directory, rm to remove a file, and mv to move a file. And last but not least, we will also try to run a jar file on Hadoop and see how you can do this. So let's get going with the next slide. So the first command that I want to introduce is the listing command. So if you're familiar with the Linux file system, you might be aware of the famous ls command. Well, the command to list the files on a Hadoop distributed file system is Hadoop DFS -ls. Now you can type either Hadoop DFS -ls or HDFS DFS -ls. The difference between these two commands is that the HDFS DFS command is a Hadoop 2 version command and Hadoop DFS ls is a Hadoop version 1 command. So I have, if you can see my screen, I have demonstrated it by typing Hadoop DFS -ls root. This means I want to list all the files and folders in the root directory, and as you can see, there is a file called movie1.csv and there is a folder called project and tmp which I have listed. So if we have to proceed with understanding how Hadoop works, the best way to do that is to create a directory in Hadoop and upload some files and practically understand how all this works. So the next command that I want to introduce is the make directory command or mkdir command. This command is used to create a directory on Hadoop. By the way, all the Hadoop commands related to the file system starts with HDFS, DFS or Hadoop DFS. So that part, the initial part starting with HDFS, DFS is going to be the same for all these commands. HDFS means we are invoking a command which is related to the Hadoop distributed file system. DFS means we want to do a file operation. So to create a new directory, type HDFS DFS -mkdir-p and root followed by the directory name. Now you have to give the complete path where you want to create a directory, and right now we are just trying to create directory in the top level of the hierarchy. So that is why I type root create _ directory, and as you can see, once I complete the command and type HDFS DFS -ls, the new directory has been created. So it has been highlighted as create _ directory. The next command is the put command. Well, many times being a developer, you want to upload your data into Hadoop so that you can analyze the same. Now, to do so, you can use the put command. The syntax for the same is HDFS DFS -put, then the file that you want to copy and the path of the file in the local file system, then the destination path in the Hadoop directory. So here I have typed HDFS DFS -put ./citytemp.txt. Well, that file is in my current working directory in Linux, and the destination is Hadoop and the directory we have just created called create _ directory. And once you do that, and after you have successfully completed the command, if I do a HDFS DFS -ls / create _ directory, you can see that the citytemp.txt file is now available. The next command is the get command. Now the get command does exactly the opposite of the put command. This command is used to download a file from Hadoop to your local file system. And the syntax for the same is HDFS DFS -get the path of the file in Hadoop and space the path where you want to save it on the local file system. So here you can see that I'm downloading this citytemp.txt file to my local file system by typing HDFS DFS -get create directory / citytemp.txt, that is my source in Hadoop, then a space and /home /user /test. So the test directory is in my Linux operating system and I want to download it to the test directory. Once the command completes successfully, I have typed ls command home user test, and we can see that the citytemp is now available in the local file system. Now, the next interesting command is the mv command or the move command. So just like the name suggests, this command is used to move a file from one place to another place, which means this is going to delete the file from the source and paste it in the destination. The syntax for the same is HDFS DFS -mv, the source path space the destination path. And I have demonstrated the same by typing HDFS DFS -mv / create _ directory / citytemp.txt space root. This will effectively delete the file under create _ directory and copy that into my root directory. And as you can see, if I do a HDFS DFS -ls on my root directory, the file citytemp is now available there. The next command is the rm-r command. Well, this command is used to delete an entire directory, and the syntax for the same is HDFS DFS -rm space -r and the directory you want to delete. So here I have typed HDFS DFS -rm -r / create _ directory, which effectively deletes the whole directory from Hadoop. Now after that, I have typed the ls command and the directory called create _ directory is no longer available. So the next command which we would be interested in performing is the jar command. Well, this is not a file operation command. This command is used to execute a program in Hadoop. So what happens is that usually when you create a program to run in Hadoop, if it is a MapReduce program and you have written it in Java, you will be creating a jar file out of it. Now the jar file contains the source code of your program, and this jar file will be used to run the program on Hadoop. So if you get a jar file, so here I have demonstrated the example using a jar file called wordcount.jar. If you want to run the command, the syntax is Hadoop space jar, then the jar file name, which is wordcount.jar, then the input path and the output path. So in my example, the input is stored in /input /input _ data, and I want the output to be stored in /output directory. Now, please remember that when you are executing a jar file, the output directory to store the result should not exist in Hadoop. You have to give a name for the output directory, which will be dynamically created while you're running the program. So this is a word count example, meaning this particular jar file has a program which will count every word in the given data set and let us know how many times a particular word has repeated. So you can see that when I type the command Hadoop jar and the jar file name and input and output, it runs. Now to verify the output, I am doing HDFS DFS -ls /output, and we can see that there is a file called part -r -00000. Now if you do a HDFS DFS -cat On this file, you can see that the result is hello 1 skill speed 1, meaning the words hello and skill speed are there in the input data set. So this is how you run a jar file in Hadoop. You don't have to worry if you don't get it for the first time. We will be exploring this further in our detailed MapReduce module and explaining the same with multiple examples. So to wrap up in this lesson, we have learned some basic file operation in HDFS. That's all for this lesson. If you have any questions, please do not hesitate to raise a. Thank you.